We've done some of the product and quotient rule, and we've worked through the problems. Now they're asking us to find double derivatives and use the same techniques. So I wrote the same 5 rules up here. Have a look for a second. We got the power rule, we got the E rule, general conjugate rule, and then the product and quotient rules are here. This is all we know, and that's all we need. Let's take the first one, f of x equals x to the 4th e to the x. Make sure we're recording here because I feel like the computer is running a little fast. Now let's look at the first term, x to the 4th, and the second term, e to the x. They're easy enough to differentiate on their own. Power rule for this one, e to the x for this one, e to the x for that one. Kind of ugly, huh? Still ugly. All right, I'll let it go. So to find the derivative is u prime v plus v prime u. And that looks fine, but if I'm going to take the second derivative, this is already 2 product rules, so I'd rather factor it like this. And go from there. So let's take another derivative. F double prime of x is u prime. So here's u prime being e to the x, right? U prime v, just the original term, plus v prime, which is going to be 12x squared, power rule, plus 4x cubed, power rule, and u, which is just e to the x. So again, we're able to take e to the x out, and what do you get? These combine, so we get an x to the 4th. I see an 8x cubed and a 12x squared. So if I want to get real with it, we could say take an x squared out and a no coefficients. So that'd be 4x squared. Sorry, that's incorrect. That would be x squared plus 8x plus 12. Heck, I can factor that too. That's going to be x plus 6 times x plus 2. And this is going to be our double derivative. Okay, that looks pretty good. You'll notice you can calculate the zeros easily from there because you have it all factored out nicely. Let's bring the rules back up. There they are. Okay, next one. Let's do the other product rule function. Maybe I'll break these videos into halves. F of x equals x to the 5 halves e to the x. So what's our product rule? U prime. Let me get my hands on this thing here. Okay. It'll be 5 halves x to the 3 halves times e to the x plus v prime times u, which is x to the 5 halves. Okay. Okay. Now we're talking. How do we take the second derivative? Well, maybe we should factor first. Let's call it x to the 5 halves. I like to put it in order of degree. And now let's take our second derivative, u prime, e to the x, so the derivative is the same, times v, which is the same. I love when it's the same. Plus v prime, this part I don't like, 5 halves, x to the 3 halves, plus 15/4 x to the 1 half, and then e to the x for u. Can any of these combine? We'll of course bring the e to the x out, but this and this come together. So it looks like I'm going to have e to the x, And then we have x to the 5/2 plus x to the 3/2, 5x to the 3/2 plus 15/4 x to the 1/2. That is going to be our double derivative. Now, if we want to put a factor of 4 in there, we could write 1/4. Looks kind of like a 2. 1/4 e to the x would be 4 x to the 5/2 plus 20 x to the 3/2 plus 15 x to the 1/2. And if you want to take a rad x out of there, well, let's just leave it at that. That's pretty close to as condensated as we can get. So let's call this the product rule examples for this problem set, and we'll do the two quotient rule ones here in the next video.